The interstellar Comet 3I/Atlas is approaching Earth. A full breakdown. The interstellar Comet 3I/Atlas continues to be one of the most closely watched cosmic visitors in recent memory. New images and data from NASA, ESA, spacecraft across the solar system, and powerful space telescopes have painted a dynamic and rapidly evolving picture of this extraordinary object as it speeds through our solar neighborhood. Although it will not come dangerously close to Earth, passing at roughly 170 million miles, 270 million kilometers, on December 19, 2025, its behavior, composition, trajectory, and activity are providing scientists and observers with an unparalleled view into an object that originated in another star system. Since first being detected in July 2025 by the Atlas Survey Telescope in Chile, 3I/Atlas has challenged expectations about what an interstellar visitor can reveal. Determination that its orbit is hyperbolic, meaning it isn't gravitationally bound to the Sun and will leave the solar system again, confirmed its interstellar origin early on. What makes this event especially compelling is not only the rarity of interstellar visitors, 3I/Atlas is only the third ever confirmed, but also the wealth of high-resolution images and diverse measurements collected as it travels through the inner solar system at tremendous speeds of over 130,000 miles per hour, 210,000 kilometers per hour. Where 3I/Atlas has been, orbit and trajectory. From the moment of detection, tracking the comet's path has been crucial. Unlike familiar comets that cycle around the Sun on predictable elliptical paths, an interstellar object like 3I/Atlas follows a hyperbolic trajectory. This means it's essentially on a one-way journey through our solar system before heading back out into deep space. Early orbital reconstructions show it approached from outside the Sun's gravitational influence, swung through the inner solar system, passed close to the orbit of Mars, then reached perihelion, its nearest point to the Sun, on October 29, 2025 at about 1.356 astronomical units (AU) from the Sun, where $1 is the average Earth-Sun distance. During that solar encounter, 3I/Atlas was immersed in intense radiation and thermal energy far stronger than anything it experienced in the cold interstellar medium. This kind of first-time solar heating after millions of years of drifting through deep space is unusual and has likely fueled much of the activity now being observed. Since perihelion, it continued outward, heading toward a distant pass by Jupiter's orbit in March 2026, where it is expected to approach within roughly 53 million kilometers of the giant planet, a remarkably close alignment that may slightly perturb its outbound path. NASA and ESA spacecraft, along with ground-based observatories, have been tracking the comet's position and motion continuously so that its precise trajectory is well mapped. Although some data hint at subtle, non-gravitational accelerations, small changes in motion possibly due to outgassing, the overall path remains consistent with an interstellar flyby rather than any captured orbit around the Sun. New images and observations, evolution of structure and tail. One of the most striking recent developments has been the release of new high-resolution images captured by NASA's Hubble Space Telescope's Wide Field Camera 3 and by ESA's JUICE spacecraft, providing a closer look than ever before at the comet's nucleus and surrounding coma. These images reveal several key features. A bright and active coma, where gas and dust are being released. Evidence of multiple tails, including dust, plasma, and gas features. Jet-like structures and variations in brightness that suggest internal activity driven by solar heating. The nucleus itself, while still too small and faint to be resolved as a solid surface in many images, creates a halo of material that responds to changes in solar radiation. Observations of this tail material offer clues about the comet's composition and internal processes. Along with visible light imagery, ultraviolet instruments aboard Mars orbiters and space telescopes have helped isolate emissions from different elements like hydrogen. These kinds of measurements help scientists understand how solar radiation and the solar wind interact with material released from the comet. Amateur astronomers around the world have also contributed by capturing images of 3I/Atlas as it passed in front of various celestial backdrops, adding to the overall dataset of observations that trace its evolution over time. Chemical anomalies, what makes 3I/Atlas different? Perhaps even more fascinating than the comet's changing appearance is the complex chemistry being detected in its coma. Observations from facilities like the Atacama Large Millimeter Array, ALMA, in Chile have uncovered unusually high amounts of methanol and hydrogen cyanide, both important molecules in prebiotic chemistry. Such enrichment is unlike what has been typically seen in solar system comets, and may hint at unique conditions in the environment where 3I/Atlas formed. While methanol is a relatively simple organic molecule, it plays a significant role in chemical pathways related to the building blocks of life. The fact that these compounds are abundant in the coma suggests that 3I/Atlas may contain a rich inventory of organic materials, possibly preserved from its original stellar nursery. Other compositional measurements indicate unusual gas ratios, including distinct differences from thousands of comets observed within our own solar system, raising questions about how conditions in another star system shaped this object's chemistry. Activity and brightness. Why 3I/Atlas is not a typical comet. As 3I/Atlas approached the Sun, its brightness increased in dramatic ways. Unlike many comets whose brightening is intermittent or follows predictable sublimation curves, this comet displayed sustained and significant changes in brightness that have puzzled scientists. Some of the expanded tail and coma structures could only be explained by vigorous outgassing of volatiles, especially as it neared perihelion. Often, as frozen objects approach the inner solar system, heat causes ices to sublimate, turning directly from solid to gas, releasing particles and creating visible activity. For 3I/Atlas, the intensity of these processes has been extraordinary, likely because this object has not been processed by repeated solar heating over millions of years as typical solar system comets have been. These dynamic changes contribute to its complex tail structures. In some images, the antisolar tail, the stream of dust pushed away from the Sun by radiation pressure, appears to have unusual orientation and shape, leading to descriptions like a flipped tail. This points to interactions not just with solar radiation pressure but possibly with solar wind and magnetic fields as well, highlighting how differently an interstellar visitor may behave compared to familiar comets. Visibility, and how to observe 3I/Atlas. While 3I/Atlas will not be visible to the naked eye for most observers, telescopes and advanced binoculars will be sufficient for many skywatchers to trace its movement near its closest approach in mid-December. NASA has emphasized that although the comet will never intersect Earth at dangerously close distances, its visibility window provides a rare opportunity to study an interstellar object in detail with both professional equipment and amateur setups. Observers are encouraged to point sophisticated telescopes toward the comet's path, especially as conditions improve when the object moves away from the Sun's glare later in December. Its dusty envelope and tail structures may be visible under dark skies with moderate optical systems. Scientific importance and the broader context. Every comet contains clues about the physical conditions and chemistry of the environment in which it formed. For solar system comets, these clues trace back to the early history of our own system. For 3I/Atlas, however, the clues may reach far beyond our neighborhood, offering a rare look into the composition of material from another star system entirely. Because this is only the third interstellar object ever confirmed, there is intense scientific focus on extracting as much data as possible before the comet resumes its outbound journey. Missions like ESA's JUICE, NASA's Hubble, Webb, TESS, and even imaging assets on Mars orbiters have all contributed observations. This multi-platform monitoring effort makes 3I/Atlas one of the best documented interstellar journeys in history. The sheer volume of observations allows astronomers to piece together not just images and brightness curves, but also spectroscopic breakdowns of gas emissions, insights into the outgassing processes, and comparative analysis against solar system objects. What happens after December 19th? After passing by Earth in late December, 3I/Atlas will continue outward, moving toward Jupiter's orbit and then on into interstellar space once again. This outbound trajectory means scientists will still have several months to observe its fading glow and evolving tail structures before it becomes too distant to track. The passage near Jupiter's gravitational domain in March 2026 may subtly alter its path, but not enough to pull it into a bound orbit. Instead, it will continue its journey as a true wanderer of the galaxy, carrying chemical and structural clues that originated far beyond our Sun's influence. Why 3I/Atlas matters. Interstellar comets are rare, and each one provides a window into environments that are otherwise inaccessible. By studying 3I/Atlas, scientists hope to better understand the diversity of chemical compositions in other star systems, how long-term exposure to interstellar space affects frozen bodies, what interstellar visitors might teach us about the origins and distribution of organic compounds in the galaxy, whether such objects could play roles in seeding planetary systems with prebiotic materials. In the broader context, 3I/Atlas isn't just a comet, it's a flyer from another stellar neighborhood, granting us a fleeting chance to study the materials and processes of a distant cosmic environment. The tale of 3I/Atlas is far from over. As this interstellar object makes its historic passage through our solar system, each new image, spectral reading, and trajectory update brings us closer to understanding not only this single visitor but also the broader story of how planetary systems and their constituent bodies form and evolve across the galaxy.